We are studying chapter number 4 in Science 1, which is effects of electric current. We have almost completed all the theory, all the information that is there. Just one major topic remains. We will cover that today. We will also have a look at what all we have studied this year in this chapter. And we also will look at certain things which are not given in the chapter, but we need to know for proper understanding of motor and generator. So our focus today will be on generator. This is what we have studied till now. We started by revising what electrical energy is, what electrical power is, how they can be calculated, how they can be measured, how they can be expressed, what the units of measurement are. We looked at multiple formulae, V, I, T, V, then I square RT, V square by RT for energy. For power, I square R, and V square by R. Energy measured in joules or watt hour, kilowatt hour, which is also called as a unit. Power in watts or kilowatts, W-A-T-T, not W-H-A-T. Then coming to the main topic of the chapter, which is effects of electric current. We have studied two effects of the electric current. One is the heating effect. We saw how it is useful for us and also how it is harmful for us. And because sometimes it is harmful for us, we can make the electrical circuit safe by using circuit breakers. Then this is the main part of the chapter. The longest part of the chapter is the magnetic effect of electric current. We understood the right hand thumb rule. We understood the Fleming's left hand rule. We understood how the electric motor works. In the last class, we understood what electromagnetic induction is. Right? And then we understood what Fleming's right hand rule is. That is what we have studied. So let us see if you have come prepared to the class or not. If you have understood some things that we have studied in the last class or not. Very simple, 2 questions, one by one coming to your screen. First one, what is required to induce electric current in a conductor? If you know the answer, if you want to speak, raise your hand. If you want to type it, go ahead, type it. The answer will come only to me. What is required to induce electric current in a conductor? And here we are looking for that unique thing without which हम कुछ और जो भी कर लें, we will not get current induced. What is it? Kritika and Anushka are saying magnetic field. No, it is not the correct answer. It is not the complete answer. Shubham Yadav is saying we need petrol. No. I know where you are coming from, Shubham, but that is not what is required. We can induce an electric current even without petrol. I will prove to you. Kritika and Anushka, you are on the right track. Now get to the correct answer. Very good, Anushka. Now you have given the correct answer. Almost correct answer. I understood what you mean. Anushka is saying what is needed is moving of magnetic fields. Anushka says, or we can say what is required is change in the magnetic field. What is required is the change in the number of magnetic lines of force that are passing through the conductor. Good, Anushka. That change in the magnetic field is required. If we say we need a magnetic field, no. If there is a magnetic field, there won't be electricity. Only when there is a change in the magnetic field, only when there is a change in the number of lines of magnetic force that are passing through a conductor, there won't be any current that will be induced. And Shubham, coming to your answer of petrol, no, we don't need petrol. If we move the armature using our hands, then also we will be able to produce electricity. If we move the armature with wind energy, then also we will be able to produce electricity. No? So petrol is not necessary. It is the change of magnetic field. It is the change of number of lines of forces that pass through the conductor. That is the right answer. One label is missing. 3 fingers are shown, stretched perpendicular to each other. The index finger supposedly is showing direction of magnetic field. The thumb is showing the motion of the conductor. Then what is the middle finger showing? Anushka, Karthik, correct. It shows the direction of the induced current or direction of the current. Aarti Bania, correct. Kritika and Alfia, just saying it shows current is not enough. I clarified it in the last class also. These 3 fingers show us the direction of 3 different things. Thumb always shows the direction of the motion of the armature. The index finger always shows the direction of the magnetic field, and the middle finger always shows the direction of the current. It is always direction. We can't just say motion or magnetic field or electric current. That will not be correct. Today we will look at what an electric generator is, how does it work, what is it made up of. Similar to what we studied with respect to the electric motor. Okay? Certain things I will tell you and certain things I will ask you to find and share with me. And as I said, we will look at certain things which are not clearly given in the textbook, but have been asked in the questions. Okay? So we will try to understand them as properly and as easily as possible. And those things are the differences between AC and DC motors, the differences between AC and DC generator. Also, what is the fundamental difference between a motor and a generator? That's what we are going to try understand in the class today. We will need to write, we will need to draw, and we will need to annotate also. Let us begin. Oh, something was missing now, and no one has sent the answer to me. This was due yesterday. So many of you told me that we use AC because you told me that it is cheaper, and you told me that it causes less power loss, right? But then I forced you to think, find out, and tell me, why is it cheaper? Why there is less power loss when we are transmitting alternating current? These are the things that you will study in much more detail if you take up science in college, and then if you take up physics in college, and even more if you go beyond college. If you study for your electrical engineering, whether it is diploma or degree, you will understand this much better. 3 main points. One is AC is safer than DC. Safer in the sense, if we just happen to come into contact with a conductor having direct current, then the shock will be much bigger compared to AC for the same voltage. That's one. Second, it is cheaper. It is cheaper because the equipments that are needed to change the voltage, the current, and these are called transformers. The transformers for AC current are cheaper to make. And the third thing is less power loss, which you rightly pointed out. When we transmit electric current from the power plant to our distribution centers, power stations, then the loss that occurs due to heat and other things is less in case of AC. And then I asked you, why does that happen? Again, we are not going into the maths, but the facts are, if the current is high, then there will be more power loss. I square R, P equals to I square R. So to reduce the loss of power, we can either reduce the current or we can reduce the resistance. But obviously, the impact of the current on the power loss is more than the impact of the resistance. So we can reduce the amount of current if we can increase the voltage for the same power that we are trying to transmit. And increasing the voltage of AC, as I told you, it is cheaper. Making that equipment is cheaper, is easier. And because we are able to transmit AC alternating current at a much higher voltage, much lower current rating, the energy loss that happens during the transmission is lesser than that in the case of direct current. And that is the reason across the world, alternating current is used, not direct current. Even then, there are certain places, there are certain things which still use direct current. You will learn about them on your own if you want to, and you will learn about them when you study more physics later in life. This is the answer we were looking for. Let us now look at what a generator is, how does it work, how is it constructed, and as you have rightly realized, if the world over alternating current is used, then the generator that we need is also a generator that can produce alternating current. I'm missing a slide. I should have included a slide as to what a generator is. I thought my students will be able to answer. Now try remember how we defined what an electric motor is. And then you try to define what an electric generator is. Try.